Hello, my name is Mackenzie Ansira, and this is my presentation for contemporary biology. I will be discussing 3D organ printing. A little introduction, 3D printing is a relatively new practice that we usually use for engineering and building buildings, but is now being used in the technology and scientific realm. 3D printing organs is still in the early stages, and according to LEV, 3D bioprinting is a form of additive manufacturing that uses cells and other biocompatible materials as inks, also known as bioinks, to print living systems layer by layer, which mimic the behavior of natural living systems. Here's a little overview. I'll be talking about why I'm talking about this, what we know about 3D bioprinting, controversies, and the future of 3D printing organs. So why I chose this. Imagine being able to just print an organ in a lab like that and have it be fully functioning and being able to put it into a human body. I think that is so interesting and very much something that could be used in day-to-day life for organ transplants. Technology has come so far in the realm of science and medical advances. It is time to put everything that is being used into practice. And it could be the future of organ transplants. So what we know so there has been research done for 3D organ printing done by the Wake Forest Institute for Regenerative Medicine and the Scientific Reports Corporation. And there have been other private studies done that have proved 3D printing has helped develop sugar stents that help surgeons in joining veins. And has also helped improve drug delivery systems. So bioprinting. What is bioprinting? It's another term for 3D printing of organs, and bioprinting is mainly used to study the functions of the body. So they could print an organ and you can study it that way. And it's commonly used in the fields of tissue engineering and bioengineering. And it has been proved to be helpful in the use of pharmaceutical development and drug validation. Electrospinning is another part of 3D organ printing, and it aids in the process. So basically a little rundown is you can take small sample of a patient's cells from the area that is going to be recreated, and then within a bioreactor, the cells are replicated until there's enough to create the organ. After this, the extracellular matrix is made and the cells are sprayed over the matrix. Ending this off, they are placed in an incubator that mimics the conditions of the human body. The machine kind of resembles like a cotton candy machine. So if you think of that, that's what it is. It's kind of like spinning, as in the name. It does, however, lack precision to make solid structures such as the heart. So this would be used more for veins, tissues, and cells, So what are some controversies with this? What are some things that could hold up the use? So, legal issues. In America right now, there is no definitive legal structure for where 3D bioprinting falls. It is kind of up in the air, and so that can cause problems with getting things approved by the FDA. If it fails, where do you go for lawsuits wise and things like that? And of course, it could be an ethical issue. So creating a organ rather than having the organ already being made and grown with you from birth can be a problem for some people and can be a hard pill to swallow, and thinking, okay, but are these actually real? Do these actually work? Is it safe? Things like that. And then the regulations. So who is making these? Are they in the safe lab conditions? Are we making sure that these are being manufactured in safe spaces? How long are these clinical trials going to take? Some people want them to take 3 years, others want to take 20 to 30 years. What is the right medium? How do we know that these are safe? And then the viability, of course, are these going to be fully functioning human organs that can be placed into a body? Are they going to pump blood? Are they going to circulate oxygen? Are they going to be able to withstand disease? How long are these going to be able to be in a body? So what does the future look like for 3D printing and bioprinting organs? So as of now, there is the company, the Wake Forest company that I talked about previously, are hoping to the next 2 to 3 years get their organs that they have made and are ready in clinical trials. So that is one known case, but I know a lot of others are still in the research phase and are still getting the kinks and making sure they don't break, they don't brittle, what does that look like in the body, and things like that. Approval. So in America, it does have to be FDA approved before, as everything else does, approved before. So that could take 2 years, 3 years, 5 years, 10 years. It really depends on who gets out there, who has the model, who has the right resources. In other countries such as Britain, you have to go through several companies and corporations like the BBSRC, EPSRC, MRC, and NC3RS. So these are all biotech and health science corporations that have to approve the structure and things like that. So transplants, what are the transplants going to look like in the future? How are we going to get a 3D printed heart into a body? What are things like that going to look like? So according to Dr. Saman Nai at the University of Saskatchewan, the organs that they are producing there should be completely functioning and should not be rejected by the body, because they do take a patient's cells and replicate it. So essentially their own cells are being replicated, which could be done in the body, but is not able to, but it's being replicated and being placed back into the body. Therefore, they should not be rejected because they are already known. Only clinical trials will be able to determine if this is true or not. So in the future, with the clinical trials, with the approval, we will be able to see how the transplants will be effectively done. Thank you for listening, and here are my cited sources.